Hey everybody, welcome back to AIT 1003. We are going to dive right into Robert Boyles Law, which is a big part of our pneumatics lesson, where he talked about the pressures and the volumes being inversely proportional. So let's get right to it again. Like I said, as long as our temperature is constant, Boyle stated that gas pressure and volume are inversely proportional, meaning that if one goes up, the other goes down. Okay, and where this is going to become relative is when I'm going to show you an entire system. We're going to make some modifications to the system, which will then impact the volume and the pressure of that system. And some of the things may or may not work based on that modification. So that's just why we're trying to figure this stuff out, because when you make modifications, they got to work. Okay. So anyway, moving forward, like I said, with increased volume comes decreased pressure, inversely proportional. Okay. Much like that, the piston going up and down in the reciprocating air compressor, we are decreasing volume and we are increasing our pressure. That's what Boyle tells us, okay? But before we can do any of this stuff, we're talking about pressures and we're talking about volumes. They're kind of two different languages. So what we've got to do is get them in their absolute form, okay? So we're going to talk about how to convert these to absolute values so that when you make your calculations, they come out right. Okay, they got to speak the same language, so to speak. So we already talked about it in hydraulics, but we know that atmospheric pressure is 14.7 psi per square pounds per square inch. Okay, that's and we have a gauge. Our gauge reads 0. It's reading gauge pressure, meaning there is no additional pressure. So when we have a 0 on our gauge, it's measuring actually 14.7 psi atmospheric pressure, but it's only going to be on a 0, it's registering 0. Anything above 0 is known as gauge pressure. So if I've got a little dial gauge here in my hand and it reads, say, 10 psi, that is 10 pounds of gauge pressure. Now, if you add the 14.7 and the gauge pressure together, we get what we call absolute pressure, and that's the numbers we are looking for and for our calculations and things. But you got to get it on in the absolute value. So again, atmospheric pressure and gauge pressure are equivalent to the absolute. Atmospheric and gauge are absolute pressure. Okay, so it's real easy to figure out. All you have to do is take your gauge plus your atmospheric, and you wind up with absolute. So in this particular case, gauge was 14.7, and that winds up with our absolute pressure. Okay. Now, in order to convert our absolute back to gauge, all we have to do is take our absolute pressure, subtract the 14.7, and we wind up with our gauge pressure. Okay, easy way to convert it. Here's one more example. We got 144 psi on our gauge on our panel. Okay, our machine says we're running our system pressure of 144 psi. All right, what would the absolute pressure be for that? Well, pretty simple. Just add 14.7 to your gauge pressure, and you wind up with 158.7 pounds per square inch of absolute pressure. All right, and again, in order to convert absolute pressure back to gauge, you take your absolute, subtract 14.7, we wind up with 144 psi gauge pressure. Okay, just that simple. Okay. Now, one thing we haven't talked about yet is absolute temperature, and again, we've got to get this into an absolute value so the formulas can, the two numbers on the formula can work together and talk together. Okay. So the same goes for temperature, but we have absolute temperature, and this is a Rankine scale. We are pretty much familiar with Fahrenheit and Celsius. This is a different scale. And the absolute 0 in Rankine scale, absolute 0 in Rankine is a minus 460 degrees Fahrenheit. Pretty cold. This is the point at which, you remember we talked about earlier about our air molecules just being chaotic, okay? At minus 460 degrees Fahrenheit, or absolute 0 in Rankine scale, our motion in our molecules ceases completely. Everything's completely still, okay, theoretically. All right, so that's what we use this for, and it's really kind of easy to convert as well. The temperature in Rankine is 460 degrees plus whatever our Fahrenheit temperature is. That's our Rankine scale. So in our dial temperature right here on this outside gauge, we're 70 degrees outside. 70 plus 460 will give us 530 degrees That should not be Fahrenheit, it should be Rankine, okay? 530 degrees Rankine, okay? That's how you convert that. Now to convert it back, to find out what Fahrenheit temperature is, because when we get done with our formulas, we're going to want to convert it back from absolute to Fahrenheit. We just simply take the Rankine number that we had, subtract 460, and that will give us our Fahrenheit number. So we had a Rankine of 530 degrees Rankine scale. We subtract 460 to get our temperature of 70 degrees Fahrenheit. So those are the formulas right there. Pretty simple to convert absolute pressures, atmospheric and gauge pressure to absolute, all right, and back. And this is going to convert Rankine or absolute zero to Fahrenheit and vice versa. So we've got those there, and then we're going to start putting them into play, okay? So here we go. Now this is the book's formula, okay? And you can work it this way, but I've got a little bit easier way for you to do it, and don't be intimidated by this at all, because we're going to go over a couple of examples of each one of these. And that's the nice thing about this video lecture. You can stop and go over it as many times as you need to until you get it, okay, until it makes sense to you. So that's the formula in the book, but there's a little bit easier way to do it. The first thing we got to do is we got to get this formula linear, okay? That means across one line, okay? And the way we do that, same formula, okay? The way we do that is we take this P1 right here and we move it over to this side of the equal sign and we multiply it by that, okay? That'll do away with that, and then you wind up with P1 times V1 is equal to P2 times V2, or that's the same thing right there. P1 times V1 equals P2 times V2. And you're going to see very quickly how you don't have to necessarily remember these, but if you get these linear, it'll make it so much easier. Now the book gives us an example of we're going to take 5 pounds of pressure, and we're going to jack it up to 35 pounds. And what has happened is that's changed our volume to 120 cubic inches, all right? So we're going to try to find out what was the starting volume, okay? This is what the P1 and P2, V1 and P sub 2, that's the starting pressure, okay? This is your ending pressure. This is our starting volume. We don't know what it is, but we do know what we wound up with, okay? So all we have to do now is just plug these values into where the variables are at, okay? I'm just going to show you real simple, all right? So let's start to begin with, all right? P1, come over here, and we're given P1 of 5 pounds of gauge pressure. Gauge pressure. We've got to convert that to absolute pressure, and we do that by adding 14.7. That's how I got a 19.7 over here, okay? So P1 in its absolute form is 19.7, okay, times V1. Well, V1 is what we're looking for, so we're done with that for right now, okay? So let's move on and plug in what else we know, okay? So we've got P2. Well, P2 is 35 pounds of gauge pressure. Got to convert it to absolute. Don't forget that. Just add 14.7 to it and drop it right there, okay? That's 49.7, okay? And we multiply that by our V2. That is our volume that we wound up with, the second volume, the one that we wound up with. We don't know what we started with here. That's what we're trying to find out. We've got a second volume right here, and it's 120 cubic inches. One thing about it, only temperature and only pressures have to be converted from absolute to their gauge, okay? Volume is volume. You just use that number, okay? So we drop our 120 into that, okay? And there's our formula so far. The next step is going to be multiply this right here by your 49.7 times 120. We wind up with 5,964 is equal to 19.7 times V1, all right? We're not quite there yet, because what we're trying to get is V1 by itself. That's what we want. How do we do that? Well, all we have to do is we have to divide this by 19.7, and anytime you do that, that will cancel out these two numbers right here. But if you do it to one side, you got to do it to the other. And so we take 5,964, divide it by 19.7. Now we've got V1 all by itself. So the volume that we started with is 302.7 cubic inches. And this is the cool part, okay? Now remember, we said that the pressure and the volume are inversely proportional. We went up in pressure from 5 to 35 psi, okay? So if it's inversely proportional, that tells me that we will have gone from a smaller volume to a larger volume, okay? All right, so we've gone up in pressure, and we had an initial volume of 302.7 cubic inches, and we went down to a volume of 120 square inches. So our pressure went up, our volume went down, okay? Inversely proportional, all right? So this is how Boyles Law is working for us, okay? Now, again, this little arrow says that whenever we divide something by itself, it cancels it out, okay? So, what if, now we're going to work it again, only this time, and we're going to use the same numbers for simplicity, okay? I don't want to throw a bunch of different numbers. This way we can check to see if we're on the right track, okay? We're going to use the same numbers, only this time we're going to hide what our second pressure is, okay? So in other words, we're going to start with a volume of 302 cubic inches that we figured out last time, and we're going to squeeze that down to 120 cubic inches, okay? Well, when we've got 302 cubic inches and 5 pounds, we squeeze that volume down to 120, Boyles Law tells us it should go up, okay? We don't know what it is, okay? So we're going to work our formula and figure this out, all right? So again, we want to make this formula linear. First thing you always do, make that thing linear. Take this P1 and shove it over here with a multiplication sign, all right? And once you do that, you wind up with that, okay? This is Boyles Law, all right? So now, let's plug in our numbers, what we know of them, okay? P1 is 5 pounds, but we've got to turn it into absolute. Remember that. Jot that down. Turn it to absolute value. So 5 plus 14.7, okay? Yeah, here we go. And then we have a volume that we started with at 302.74 cubic inches, right there. Just plug that in right there. Then we're looking to see what our pressure is. That's what we're looking for. P2 is what we're after. So we don't know it yet. But multiply that by V2, which is our ending volume, our second volume. The volume we're going to is 120 cubic inches. And then we just do the math from there, okay? So again, we're going to multiply 19.7 times 302.74, okay? And we're going to wind up with P2 equal to P2 times 120. Now, we want to get P2 by itself, okay? So we we divide this side by 120. These two will cancel out. Remember, if you do it to one side, you got to do it to the other, okay? So we got to divide this side by 120, all right? So keep going a little bit further, and we wind up with this right here equal to 5,964 divided by 120 is going to give us P2 all by itself, all right? And if we do that math for us, we're going to wind up with these 5964 divided by 120. It's going to give us 49.7 pounds per square inch absolute. But we want to go gauge, right? Okay, so to get the gauge, we just have to subtract 14.7. So 49.7 minus 14.7 is going to give us our P2 value of 35 psi, okay? If you remember from the previous problem, that was the pressure that we jacked up to. I just took that variable out so we could make sure the numbers worked and they all came out right. So, as you can see, we proved that if we add volume to our system, we're going to lose pressure. Also, if we decrease the volume, we're going to gain pressure, okay? So, Boyles Law has already started proving itself a little bit. And we're going to take a look at it in the next lecture, next section of this Boyles lecture, and we're going to see how it works in the system. But for right now, I just want you to kind of chew on that. Watch this again if you have to, get it to make sense for you. Some of you may not have had math in a while, and that's okay. Come to the lab. We will help you if you need it. But really, I think you should probably get it based here on the lecture, okay? So shut this one down. Come back for Boyles Law number 2. It won't be nearly as long. We're going to put it into an application, and you're going to see where this is all starting to come together. So other than that, just shut her down and take a break, review this a little bit, and then come back for the second one, okay? So thanks a lot for watching, and we'll see you in a little bit.